So in part 9, we're going to look at some more advanced design topics. I decided to skip these in the earlier sections. They're not necessary in every network, but there are things that you need to consider, and we're going to talk about them now. So, actually, I should say security is always important, but we're going to look at other applications and things. And the first important design consideration is the number of users, or I should say number of devices, because a user may have several devices, and if you've got too many devices on your network, they will overload the AP. And the first way they can overload the access point is if you've got 100 or 200 devices and they're all trying to establish a connection with the AP, then its processor will get overloaded and crash, just like a computer. And the second way that it can crash is it's only got a certain back-end LAN connection. So you've got one data cable going back to your switch. So even if you've got a small number of devices connected to your access point, if they're all doing video conferencing or something, then they're not all going to get the traffic that they want, and the LAN connection will become congested. You have to remember that each LAN connection, each user, the AP is adding its management traffic, and the LAN is adding its management traffic on top of the actual data. So the amount of data connection that you think you have is actually less. And there are ways to avoid this. One of them is traffic shaping. You can throttle users, or you can throttle applications or ports. Some access points have dual connections, which are always appreciated in these situations. So 40 to 60 devices can overload an access point. If you've got a room, like in a classroom, an auditorium, a waiting room, an arena, then your access point has good signal strength in the room, but what it doesn't have is a capability of handling all the devices. So in that case, you have to add more access points to the room. So you might have a room that's 100 feet wide, and you need 5 or 6 access points to handle all the devices. And then, of course, you can use a much larger overlap. Just make sure to change a channel on each AP so that the overlapping access points have different channels. And also can consider if you've used a cloud managed access point or certain access point controllers, they can automatically configure the channels to avoid the interference. So what you need to consider again is the number of devices connecting, the type of AP you've installed, how powerful is it, its encryption protocol. Encryption makes an AP slower, so encryption means that access point can handle less users. Think about what kind of connection you have between the access point and the switch, how much data is being transferred by each device. So are people watching movies, or they're just checking their email? That's going to impact the number of users you can handle. What kind of devices they're using, cell phones, tablets, computers, and also the percentage of time a device is active on the network. So we find People in a conference room, they're all talking. They may not necessarily be doing things on their laptop. If you look at people are watching a football game in a stadium, they're not on their phones, they're watching the football. And then when the team takes a timeout, everybody gets on their phones and starts tweeting and watching video and whatever. Now Wi-Fi use goes from, say, 20% to 90%, and you need to be able to accommodate that. Manufacturers put out specs. Of course, their specs are based on controlled tests. They don't actually work in the real world. So, yeah,